are in listen-only mode.
Okay, good morning everyone. If you're on the East Coast, if you're somewhere else, hello. This is Jim Lewis, and I'm president of the Lewis Institute and an instructor with NC State University Office of Professional Development. And the webinar that you're going to be part of at this point has been produced by students in my class, which is called Project Management Tools, Principles, Practices. And after this class is over, we will post the PowerPoint slides with notes and that sort of thing on another website for you to download, but unfortunately we don't have them at the moment. If you are interested in finding out more about our Project Management Certificate Program here at NC State, there is a link here that will be contained in those PowerPoint notes, and we would invite you to go to that link and check things out. Again, the notes will be posted to MediaFire, but they are not there at this point in time. Our first presenter is going to talk about defining project failure. This is Joe Perez, and I'll let him take over the mic at this point. And if you have any questions, you can type questions in. We will try to take some of those at the very end of the webinar. And if we don't get to all the questions before the webinar is over, we will email responses to all of you who ask questions of us. So thank you for being here, and here's Joe.
Thank you, Dr. Lewis. Good morning. My name is Joe Perez. As Dr. Lewis mentioned, our team is tasked with defining failure, part of what we call Team A. And Team A is comprised of Angela Liu, Ben So, Caleb Brown, myself, and Nikki Harris. Okay, so what is failure? Well, a dictionary might tell you that it's the lack of success in achieving a specified or desired outcome. But really, in the context of project planning, pinning that definition down can be sometimes difficult because there are both objective and subjective ways of judging success or failure of a project. Now, there are some projects that succeed when you measure them by objective metrics, right? But subjectively, you might consider them to be a failure. And there's other projects for which the opposite's true. Let me give you an example. A surgery on a patient being successful in and of itself, but do you still call it a success if the patient dies soon thereafter? So for the sake of time, our presentation today will focus on the objective metrics that drive and constrain projects. Now, other ways of judging project success outside of the execution of the project itself could be such things like value added to the organization, whether or not you have an appropriate ROI, and whether or not your customer is going to adopt the product that you've designed. See, all these are, of course, important to consider from an organizational standpoint, but we won't be covering them in today's webinar. So, with that in mind, we define failure as, that is, in the context of project management, failure to meet one or more of these four primary project metrics called performance, cost, time, and scope that results in the failure of the entire project as it pertains to the organizational goal. Now, we're going to refer to these four metrics, performance, cost, time, and scope, as the four pillars, as you can see the picture in the background of these four pillars. And you'll often see them abbreviated in the project management world as P, C, T, and S. Now, these metrics are used to define the parameters of the project. Now, you know as well as I do that having appropriate targets for these areas is critical if you really want success to be a realistic and achievable possibility. And let's face it, if you have unrealistic targets, well, your project's going to be set up for failure from the get-go. It makes no difference at all how well you may be managing the project or executing it. See, realistic expectations for these metrics, well, that can be set only by leveraging the people who you have working on the project from the very beginning to help define these metrics. The other student teams are going to be discussing this in a bit more detail in the webinar. Okay, so let's take a look at each of these four pillars. All right, first of all, we have performance. It's quite straightforward. This pillar is going to come tumbling down when the deliverable doesn't meet the requirements. Now, in this area, Things like subjective validation, complexity of the project, poor quality implementation, and when you don't address requirements and expectations of your customer base, these are the kinds of things that are going to have the most negative impact. Now check out the guys in this cartoon, right? Simply churning out more activity isn't going to solve the problem. Oh sure, just do 140% of the projects and you'll get a project success rate of 100%. Yeah, right. Like that's going to work when the customer's telling you, well sure you got it done, but you produced an inferior product. Who are you kidding? And what do you have here? Absolute failure. Second pillar, cost. The cost pillar, this thing collapses when the project's allocated budget is exceeded. Now you may have heard it said, well, I don't have too much money left at the end of the month. My problem is I've got too much month left over at the end of my money. As you know, dollars and cents, of course, speak volumes. They sure do. And this is obviously an objective validation. You know, you may have grossly underestimated the budget you needed, or maybe there was some poor procurement planning going on here that led to expediting costs. Maybe somebody has expanded the initial scope without accounting for the additional costs incurred. In any case, you can end up like this penniless pachyderm here, and the customer might say, well, sure, you had a decent project, but you know what? It costs too much to get it done. Once again, we have failure. Okay, the third pillar, time. Failure of this one happens when the project isn't completed within the allocated time frame. Now, it doesn't take a rocket scientist to figure out that each project and activity has timelines to meet. And, you know, when each activity doesn't stick to the delivery schedule, well, of course, that's going to affect other activities downstream. We call that the snowball effect. As with the other pillars, I guess some of the contributing failures here include underestimating the duration of time for each activity, that's poor planning, or scope creep, which is going to be talked about a little bit later on. Somebody imposed an impossible deadline or even a change in organizational priorities. And it's even worse when you are the last one to know. The question you might hear from the stakeholders here is, okay, how much longer are we going to have to wait to get this thing? And it's pretty obvious that the guy in this cartoon here, well, he doesn't even have a clue on how to answer that question. Once again, he is definitely doomed to failure. All right, that brings us to scope, the fourth in our quintessential quartet of pillars here. This thing will go down when our stakeholders don't get what they asked for. Now, remember, we're using stakeholder and customer pretty much interchangeably here. Keys to failure: poor communication, poor interpretation. Give you a couple examples. First of all, guy says, I want a spoiler. Okay, well, without proper communication and interpretation, you don't know if he's going to get something that looks like that first picture or something that looks like that second picture. I don't even want to tell you what I think that thing looks like. Now, second example, a classic. I really love this one. It's my favorite illustration of total breakdown of communication with regards to scope. Now, it's clear to me that this thing's got to be an example from the IT world. Now, I can say that simply because I work in the IT business, or at least my position still is, and hopefully still will be by the time this presentation is over in the IT world. All kidding aside, look at the panels. Okay, first of all, focus on the top left and the bottom right. Now, doing so, you're going to see right away that there's definitely a disconnect between what the customer said they wanted and how it was understood. You know, it's equally obvious, though, that the customers weren't really clearly articulating what they needed. I don't even think they know sometimes what they do need. You know, we get into trouble when we don't differentiate between what the customer needs and what the customer wants. And I really think it's our job to try to tease that out as much as we can. Again, failure to do so, well, then you're going to have a monstrosity like the one you see in front of you on your screen. Okay, the second panel shows how the project manager interpreted it. Again, we see still another disconnect. The slide's connected, the ropes are connected, but it's not connected in the right way. What can you do with a swing that looks like that? Okay, and you look, as we progress, or regress maybe is a more accurate term here, from left to right, it goes from bad to worse. The engineer sees it as a technical interpretation rather than a practical one, and pretty soon we have nothing more than an exaggerated Rube Goldberg device from Hades that's on steroids or something, you know. Okay, bottom left, look at that panel, and you can see very clearly why I think it's an IT example. No documentation. And moving on to the right, by the time you want to support it, well, how can you support it? Because by the time you get to the help desk, the whole tree's been cut down. How can you support that? You really can't. What do you have? Again, failure. Why? Failure to communicate. Failure to appropriately interpret and listen to the customer. If that had been done in the first place, then perhaps you wouldn't have ended up with no tree, no slide, no swing, no nothing. You're doomed to failure. So that brings us to our last slide, the project management overview. Candid and expedient communication facilitates the successful planning, management, and execution of the project throughout all of your phases. And a great way of setting up a project for success, as opposed to failure that we've been talking about all along here, okay, is by including the execution team from the very beginning in the project planning phase, such as in developing the work breakdown structure, the time estimates. Now, the work breakdown structure, the acronym WBS that you'll see in the project management world and will be talked about a little bit more later on by one of the other teams, these can be used to drive discussions around the development of the metric targets, and then you can make adjustments to these to either meet or change expectations. And speaking of change, you can reduce the scope to meet cost targets or change the cost to meet schedule deadlines. Whatever the case, again, I can't stress it enough, because of the critical role of communication, poor communication can become a primary reason for project failure. So remember, the failure of only one supporting pillar can lead to the collapse of an entire building. And the failure to keep to these four pillars, performance, cost, time, and scope, well, that leads to the failure of the entire project, and nobody wants that. Thank you.
Okay, good morning. My name is Henry McIntosh, and I'm on the Team B illustrating statistics for project failure. Members of our team are Ted, Steve, and Annette, Allison, and myself. And first, we'd like to start out by illustrating a couple of examples of project failure. One of the most famous examples is the Denver Airport automated baggage system. Originally billed as the most advanced system in the world, but this baggage handling system was to become one of the most notorious examples of project failure. Once the airport had been completed, it sat idle for 16 months while engineers worked on getting the baggage system to work. The delay added approximately $560 million to the cost of the airport. Even the portion of the system that was implemented never functioned properly, and in August of 2005, the system was scrapped altogether. The $1 million monthly cost to maintain the system was outweighing the value the remaining parts of the system offered, and using a manual system actually cut costs. The Central Artery Tunnel Project, known unofficially as the Big Dig, was a mega project in Boston that rerouted Interstate 93, the chief highway through the heart of the city, into a 3.5-mile tunnel. The Big Dig was the most expensive highway project in the United States. It was scheduled to be completed in 1998 at an estimated cost of $2.8 billion in 1982 dollars. The project was not completed, however, until December of 2007 at a cost of over $14.6 billion, and the Boston Globe estimated that the project will ultimately cost $22 billion, including interest, and that it will not be paid off until the year 2038. The project concluded on December 31st in 2007. Formal construction of the Sydney Opera House began in March of 1959, and the project was built in 3 stages. It was formally completed in 1973, having cost $102 million, The original cost estimate in 1957 was $7 million. The original completion date set by the government was January of 1963. Thus, the project was completed 10 years late and over budget by more than 1,400%. The construction industry provides jobs for 7.7 million employees, or about 5% of the total workforce in the United States, and accounts for 9% of the nation's gross domestic product. 57% of new construction firms are no longer in business by the end of their fourth year, and 70% have failed by the end of 7 years. The average rate of failure among projects in the U.S. construction industry is almost 14%, and the average rate of failure for all other industries is measured at 12%. 9 out of 10 construction projects had underestimated cost, and overruns of between 50 and 100% were common. In the pharmaceutical industry, the U.S. has the world's largest and wealthiest pharmaceutical market, accounting for around 48% of the world's total. The FDA received only 23 applications in 2003 for new drugs. The failure rate for new drugs is 87%, with $1 billion cost to launch a technically successful drug to the market. And the average time is 12.5 years to get that drug to market. In the United States, we spend more than $250 billion each year on IT application development of approximately 175,000 projects. The average cost of development for each project for a large company is $2.3 million, all the way down to $434,000 for a small company. According to the Standish Chaos Report of 2009, 83% of IT projects struggle with major problems, with almost a third of all projects are canceled. And the reasons for failure are many. Also from the Standish Group, here's a chart that outlines projects that succeeded, were challenged, or that failed over time. The overall challenge category dominates project outcomes, and the proportion of such outcomes have remained about the same over time. This graph highlights another key point, that large projects are much less likely to succeed. One can reasonably assume that the chances of success continue to diminish rapidly as the scale of the project increases. So if we add an order of magnitude to the $10 million upper end, we could expect there to be almost no chance of achieving the original cost and schedule estimates. This graph shows the trend in cost overruns over the past decade. Although progress has been made, the most recent cost overrun figures in 2004 at this time were 56%. So a software project with a budget of $100 million and a 5-year schedule could expect to exceed cost by more than $50 million and overrun the schedule by more than 4 years. In 2008, the British Computer Society published the results of research that looked at 214 projects across a range of sectors within the European Union. Interviews were conducted with a selective number of project managers in those areas. Research highlights that only 1 in 8 information technology projects can be considered truly successful, failure being described as those projects that do not meet the original time, cost, and quality requirements criteria. Overall, the British Computer Society says that 1 in 5 projects overruns by 70%. The Standish Group Chaos Report reports that 43% of projects have an average cost overrun of 43%. 71% of projects are over budget, exceed the time estimates, or had too narrow of a scope. 31.1% of projects will be canceled before they ever get completed. That'll be the end of our statistics module.
I'm Andrea Sapienza, and I'll be talking about the common causes of project failure. I'm presenting on behalf of my team, which is comprised of Elizabeth Ellingson, Nathan Holder, Amy Littlejohn, and Jason Epley. Obviously the causes of failure really could be nearly infinite, so we tried to break the projects down into something a little bit more meaningful, and so we broke it down into a planning phase and an execution phase where we could identify common areas that projects frequently fail. So we have planning and execution. In the planning phase, there's probably no better illustration of precise execution of a poor plan. There are quality products installed exactly as designed to be installed, and it's still equaled an epic fail because the plan was flawed from the very beginning. It would be comparable, not having a plan would be comparable to being dropped off in downtown Chicago without any roadmap or GPS and trying to find your way to any given Hilton. So the first part of planning would be to design a roadmap. So without a well-designed roadmap or project plan, you don't have any idea which direction you're going. So a roadmap would include the what, when, where, how, etc., all the details of the project. And in addition, part of the roadmap needs to include a clear understanding of the customer's expectations. As you know, frequently customers' expectations, requirements, and deliverables may not be realistic. And at the beginning of the project, during the planning phase, is the time to really identify the customer's expectations and ensure that they are realistic and achievable by your company. Another aspect of planning that frequently is overlooked is it's often culturally unacceptable to consider contingencies for if particular parts of a plan fail. And this is an enormous oversight on many companies' parts because there are numerous places that contingencies could be built in that when they're not built in that they can come back to haunt you. We all know that a skyscraper for $1 million in 30 days or less is unreasonable, but many times that's really what we are either knowingly or unknowingly agreeing to. Either we don't understand that that's what the customer wants and expects, or we do understand and we fail to acknowledge that that's really not reasonable. And so the next phase of projects where failure can frequently occur is during the execution phase. If you've well planned out an elaborate meal that includes appetizers, a meal, dessert, and partway through you burn the meal, it was still a well-designed plan, but the execution just failed to meet the plan. Oftentimes, a lack of resources contributes to project failure. So inaccurate estimates during the planning of projects can lead to a poor roadmap that might not afford you the number of people you need with the adequate skill sets at the time you need them. Some of the results of inadequate or lack of resources is a lack of commitment from your team members. And it also can result in the lack of your executive sponsorship. So really there's kind of a disassemblance of all team members when there's not a cohesive a plan for all of your resources. People don't know if they're kind of coming or going or what the expectation is of them. Another area during execution that often leads to project failure is a lack of project controls. So this is monitoring the project as you move forward. Obviously, you have to have a really good roadmap to be able to follow whether you're on making progress with your timelines, your budgets. Are you meeting deliverables? Are you moving forward as expected? Part of controlling the project is having an awareness of scope changes and whether or not they're accounted for in terms of costs, resources, the impact to your timelines. Poor project control occurs often in projects when little or no project management time is budgeted for a project. So that does take time, and when you're a working project manager, really it's difficult to oversee the project when you're a working project manager. Not impossible, but should be part of your roadmap if that's indeed the way that a project is designed. Another contributor to project failure during execution is poor communication. So frequently people are going in different directions. Team members don't have the information that they need when they need it. And ultimately what happens is a lack of commitment from team members to the common goal. They may not even know what the common goal is. If the common goal changes slightly, they won't know. And also, issues and changes aren't escalated as appropriate. And in summary, there are many, many common causes of failure. I think this one has a lot of aspects. I think Charlie Brown probably failed to prepare appropriately. He could have maybe worn cleats. It would have been a good idea if Lucy was a more committed team member, and more importantly, it does appear that Charlie Brown has failed to learn from history. There was a lesson to be learned. I do not believe this is the first time that Lucy has performed in this manner.
I'm Jane, and I'm going to be talking about things that project managers and project teams can do to prevent project failure. I'm presenting on behalf of Team D, which consists of me, Debbie, David, Deborah, and John. Preventing project failure begins at the very onset of the project, when the vision and the requirements for the project are developed. It's important here that all of the stakeholders, which would include senior leadership or management, the project team, and the end users of the product need to be involved in developing a vision of what the project will look like when it's done. And they need to all buy into that vision once it has been finished. Once the vision and the requirements are determined, developing a plan for the project becomes critical. The first step is to list everything that needs to be done. In project management terms, this is known as developing a work breakdown structure, as was mentioned in the first section. Once that work breakdown structure is in place, the schedule and the costs can be estimated. When possible, it's best to develop the cost and the timing estimates based on history of similar tasks that have been done in the past. Project teams should avoid using ballpark estimates, as those tend somehow to turn into targets that the team will be held accountable for. And we all have had that happen sometimes, usually not with very good results. Project teams want their project plan to have the right amount of detail, not too much and not too little either. So a good guideline here is to plan in the level of detail that you can control in your team. And we'll talk a little bit more about controlling projects in a minute. The people who do the work should be very involved in the planning. And once the plan's done, it should be reviewed to see if it's reasonable and realistic. During this review, team members should be encouraged to express any reservations that they may have with the plan, and those reservations should be addressed because, once again, buy-in is very important to the plan. In order for a project to be successful, the team should not ignore risks. All projects have risks attached to them. So the team needs to identify the risks and rank them according to at least three things: the probability that they will occur, the potential severity of the impact if they do occur, and the likelihood that the risks can be detected ahead of time. Once risks are assessed in that way, the team can determine whether or not the risks need to be addressed, and if so, how to respond to those risks. And for larger projects, a formal risk management plan may be needed, although for smaller projects, a lot of times these kinds of things can just be done through discussion. Keeping the project scope appropriate happens both in the planning and in the execution phases. As we discussed earlier, the project plan can only set 3 of the 4 key variables, those being scope, time, cost, and performance. Then the 4th variable is determined by the other 3. So in other words, if the time, the cost, and the performance are fixed, the scope cannot be determined independently of those other 3. Once the project has begun, scope creep, which happens when people add little things to the project, one after the other, can be avoided by evaluating the effects on the project of any requested changes and by requiring the person requesting the change to sign off on those impacts. Now, tracking and controlling your project is very important. If the folks doing the Denver Airport project that was discussed earlier had properly tracked and controlled their project, they would have known earlier than 4 days before the project launched that it was 13 weeks behind schedule. A key aspect of tracking and controlling the progress of a project is regular and accurate feedback from the project team members. We feel that this is really best done through face-to-face interaction rather than through written reports, if possible. There are a number of options for formal project tracking, including very detailed quantifiable project performance systems such as earned value management. It's also a good idea to hold milestone or gate reviews at critical points in the project to determine whether or not the project should continue. Finally, as has been mentioned throughout our webinar today, communication is key to many aspects of successful project management. The stakeholders and team members need to share the vision and the mission for the project, and the plan needs to specify clear roles and responsibilities. It's key that the team interacts frequently with senior management to keep the project on senior management's radar and to get their feedback. Again, for larger projects, a formal communication plan may be needed. So in summary, some important ways that a project team can avoid project failure include locking down and obtaining the buy-in of requirements, planning realistically and in the right amount of detail, identifying risk, avoiding scope creep, keeping projects on track, and communicating clearly.
Thank you, Jane. I'm Kate Jara, and I'm going to talk with you about what senior managers must do to reduce project failures. I am delighted to present on behalf of the lovely and talented and very funny Team E. We're going to talk about several issues. Some of these you might recognize from the other sections, specifically things like managing expectations and scope creep. Senior managers are sometimes the client, sometimes they're overseers, Sometimes they're responsible for interfacing with and managing project sponsors. We are going to talk about some of these themes that we found when we were doing our research. We're going to give you some examples as well using the Boeing 777, the 777 airplane, a plane that has millions of parts, and we'll talk about the design of that plane and how it was managed throughout the process. We'll start off with communicating and setting clear expectations. This was the most common theme from our research, as you heard from the other teams. Recall from some of the earlier examples of the spoiler and the tire swing, and how expectations aren't always communicated very clearly, and if they're not, then they're often not going to be met. As a senior manager, you want to make sure that your team not only knows what the scope of the project is, but agrees that it can be done. Just communicating what they should be doing isn't enough. They need to agree to those final endpoints. Many of the other issues that we're going to talk about in a few moments link back to these expectations. When Boeing was planning the 777 in the late 80s, the market was very competitive. What they did was they worked very closely with their customers to design the aircraft, mainly with United Airlines, because they were the first airline to have the 777 in their fleet. They wanted to make sure that they agreed on the vision. United wanted an aircraft that had lower operating costs, lower fuel costs. United communicated why they wanted this. They wanted a plane that would give them both short range from Chicago to the continental United States, as well as intercontinental range to go to Hawaii or to go to Asia. They let Boeing know the approach. Boeing worked with 8 airlines, including United, and they took an approach from Ford Motor Company to use all of this communication, use all of this feedback when designing the 777. When United was ordering the aircraft, they also set forth some guidelines. They said that it had to weigh less than 304,800 pounds. And for each pound they were over that weight limit, Boeing would have to pay them a charge per pound to make up for the fuel recovery. These communications, again, were very clearly set and were agreed to at the outset of the project. Senior managers must be involved in the projects they're working on. They might be over many different projects with different distinct teams. They need to know where the overlaps are to make sure that the teams integrate there. You're not going to, just like Boeing didn't have weekly conference calls with all of the designers and manufacturers and contributors and pilots to get all of their feedback and see where they were with the design. That would have been a waste of time. It would have been information overload. What they did instead was they ensured that the engineers didn't create their designs and then blindly pass them over the wall to manufacturing. They made sure that since these systems had to be integrated, that's where the senior managers were involved. That's where they managed this integration. You've all heard about keeping an open door, or having an open door policy, but don't just pay this lip service. Team members often don't communicate problems. They might be afraid that they're going to be punished for making a mistake. Or if you're not involved, like we just talked about, they might think that you don't understand the problem and that it would be too much effort to explain it to you for you to be able to contribute. Or they might simply just think that you're too busy to deal with what may or may not be a minor issue. You can't solve a problem if it's a secret. And getting to the end of a project, having an issue, and saying that you didn't know about it isn't an excuse for project failure. What senior managers must do is support a culture of open communication. You also must be involved enough that if an issue does arise, you're able to jump in to help, not spend time catching up on what's already happened and where it went wrong. If a problem at Boeing had been left to the very end, we might not know the 777 airplane. It has been a very successful airplane, and to date, there have been no fatalities of passengers or crew. This speaks to the success of the design of the aircraft. Several teams have already talked about scope creep. And if you're getting a chuckle at the scope bottle creeping in the bushes, thank Jeff Smith, our illustrator extraordinaire. If you are managing a project sponsor and they're requesting additional scope creep, just like the group before said, you might want to require having a signature, a sign-off for these changes. Explain to them how the change in scope could affect the other 3 pillars of project management. The performance, the quality of the project might go down if they change the time or if they lower the cost. The 777 was the first fly-by-wire commercial plane, but instead of using a joystick-type control that was common in fighter planes, which used fly-by-wire, they used a yoke like the other commercial planes. When they were doing that, they brought in a pilot to help with the design, and the pilot asked for a control called flight envelope. And it's a control that helps prevent stalls by shaking the yoke when the plane is getting to a point where it might stall. This was not already built into a common yoke. It was something that had to be created artificially. This was scope creep. This was something that wasn't originally in the design. They discussed the time that it would take, they discussed the cost that it would take, and ultimately they decided that the quality of the flight and the safety would go up enough that the scope was increased. Scope creep can be acceptable as long as you weigh the costs. If you, as the senior manager or the client, make sure you know what you're assigning before you assign the project. Make sure you know what you want. Plan the project. Then set those expectations and agree to them with the team. If you're a senior manager, you've presumably led similar projects to the ones you're managing. So you have a unique view, both on ground and 30,000 feet above. You've done it before, so you've got the granular experience to draw from. But because you're overseeing many different projects, all of the different facets of the larger project, you've got the big picture view as well. If you're involved, you can see these warning signs, and you can help the project manager or the team mitigate those. With Boeing, they saw that in the past, engineering and manufacturing operated in silos, and that was not how they thought they were going to build an effective and successful plane. So they used their experience, both on ground and their overview of it, to ensure that those 2 groups were integrated. In terms of managing strengths, as a senior manager, you might be designing the team. You'll want to ensure that there are enough people, enough resources on the team. You'll also want to make sure that the team members have the right skills, have the unique skills that you're looking for on that particular project. As a senior manager, you might also be choosing the team leader. This might not be the obvious choice. Experience on the project might outweigh management experience. When Boeing was designing the plane, they didn't just get their information from people who had designed planes before. They got input from pilots, from customers, even taking the passengers into consideration when designing things like overhead bins that drop down instead of having to put your luggage over your head to store it. These were all different, unique views using the strengths of the different customers. To summarize, a senior manager's role is different from that of the project manager or any other team member. Many project failures can be prevented by following these recommendations. At the beginning, I mentioned that Boeing and United agreed that the plane must weigh less than 304,800 pounds. After these millions of parts were designed and assembled, It came in 300 pounds underweight. That was a project success. On behalf of the entire class, thank you. We're now going to open the dialogue for questions. You might need to click the red arrow on your control panel. If we are unable to answer your questions within the hour, as Dr. Lewis mentioned at the beginning, we will be sure to email answers to your questions following the webinar. Again, if you have questions, you might need to click the red arrow to open your control panel, and then in the questions section you can type in the question and we'll answer that in the classroom. See? Cheryl McKenzie says, wow, I'm impressed. Great job. We have projects going on all the time, and you gave me many areas to check. Thank you, Cheryl. We do appreciate the feedback. Okay, now they're coming in. The most common failure we see in our job discipline. Who would like to take this one? What's the most common failure we see in our job discipline?
Underestimating the scope and cost, underestimating the estimating part of it.
Estimation, underestimating scope, underestimating cost. Poor communication. We found this in our research. Many of the groups mentioned this as well. Lack of communication, poor communication, and certainly poor estimations. Have a question. Do we have examples of risk mitigation plans?
Adding schedules is common in construction.
Adding schedules. Padding schedules is one common thing. If you think that the schedule is going to be tight, adding a little bit of extra time in there. Potentially padding costs. If you're not sure how to do an estimate, instead of saying between one number and another number, using a not to exceed estimate.
Consensual estimating.
Consensual estimating is another term that we used. That's where a minimum of 3 people are going to independently estimate how long it's going to take or what it's going to cost. And then after discussion, you come to some agreement. Matthew asks, what's the best way to get a project back on track after a major issue comes up? Replan. During any project, anytime you're having issues, anytime you are checking and seeing that it's not on plan, you'll need to adjust that plan, replan. It depends on what the issue is. If it's time, it's going to be a very different mitigation plan than if it's cost. Feedback is that this was a very helpful webinar. Let's see. Do we have any suggestions as to how to actively manage risks?
Constantly asking, what if this happens? What will I do?
Not sure if everyone can hear. Dr. Lewis is saying constantly asking, what if this happens? What will I do? Not only looking at your history to see what might have gone wrong in the past, but thinking about worst case scenarios. What if there's bad weather, or what if the technology fails? And then planning for that. Having a plan A, B, C, D, E, F, and G, not just a plan A and a plan B. Do we have templates or examples of a well-run project?
They are out there, but we don't have anything.
We don't have anything right here, but they're certainly out there. Doing some research on the 777 project is certainly one of those. Failure modes and effects analysis, one means of risk management for large projects. Yes, certainly. We've got a few minutes left. If there are other questions, please keep them coming. Let's see. What project management software do you prefer?
It depends on the size of the project. If it's a really large project, Primavera. Smaller projects, Microsoft Project, or Concept Draw.
Primavera for large projects, and for smaller projects, Microsoft Project or Concept Draw. We've got one more. If the project has already gone over schedule, team members have left the team, oh goodness, Raymond, I'm sorry, and stakeholders do not have buy-in, should the project be replanned? Well, Raymond, first I'd update your resume. No, I'm just kidding.
Good response.
Well, Dr. Lewis says not kidding. Certainly some replanning is in order.
Or cancel.
And canceling is damage control. That's certainly an option. It depends on how far into the project, what the ROI is going to be in the future. But I would keep that resume updated just in case. Great. Thank you very much. If any other questions come in, we will answer them via email.
All right. Thank you, Kate. Again, thanks to all of you who attended the webinar. We hope you've gotten some useful information, and we will be doing these programs in the future. I want to thank the people in this class. They worked really hard on this. I gave them a very limited amount of time to prepare it. So this simulated a real-world project where they had limited time, limited resources, no funding, other than we fed them well at lunchtime, hopefully. And I think they did a great job. So thanks to all of you, and take care of yourselves.